Okay, let's go over some questions. If you submitted questions and we didn't get a chance to cover them, we're going to cover them in some post-conference videos. So I'll try to make sure I'll answer all the submitted questions that came in during the course. But let's go through the first one here. How do you tell whether an infection is associated with molecular mimicry, bystander activation, epitope spreading, or cryptic antigens? So this is actually a really good question. It's a little premature because I'm going to actually explain all these things to you in part 2. And for the most part, molecular mimicry can only happen when the amino acid sequence is identical. And the most common pathogens that cause molecular mimicry with the thyroid are H. pylori infections, which are the most common infection in the world. Those antibodies can actually bind to the thyroid and promote cross-reactive responses. And hepatitis C, which is one of the most common chronic viral infections. And 50% of hepatitis C patients are asymptomatic, and more than 50% of patients that have H. pylori are asymptomatic. So we'll go into molecular mimicry in much more detail tomorrow and talk about how pathogens play a role. This concept called bystander activation, epitope spreading, and cryptic antigens we discussed in the autoimmune module. But they also all occur in Hashimoto's, and I'll specifically tell you how it impacts Hashimoto's with each of these known mechanisms. So thank you for the question. Let's go into the next one. Do you still do things to modulate Th1 and Th2? I found incredible results doing so with my patients, but there are many contradictory things out there in terms of what stimulates Th1 versus Th2. Do you have new information in this area compared to 5 years ago? So in my thyroid book that I wrote in 1999, why do I still have thyroid symptoms? My lab tests are normal. I discussed this whole Th1, Th2 phenomenon where certain botanicals stimulate the Th1 side and certain botanicals stimulate the Th2 side. And this isn't a polarized autoimmune response. It's different than non-autoimmune diseases. One of the key features that's different between autoimmune disease and non-autoimmune diseases is that there isn't a polar shift to one part of the immune system. So most people that don't have non-autoimmune disease have a Th1, Th2 system. One could be a little bit higher at the other at different times for different various reactions of the immune system, but they're pretty stable. Autoimmunity, there's sometimes a significant shift to one side. The Th1, Th2 activity, their baselines are much greater. And we used to be able to do a test called a cytokine stimulated test where they take T cells in a dish and they expose them to an antigen like pokeweed mitogen, and then you can see which cytokines get released, and you can see which side of the T cell response autoimmune disease patients were primed towards either Th1 or Th2 side. And then what we also found was that there's different botanicals that have an impact on the Th1 or Th2 side more. And for the most part, I put these in my thyroid book, but the Th1 stimulators were things that are typically known to enhance immune system support, like echinacea, astragalus, all the different types of mushroom species like maitake, alpha-beta-glucan. They were clearly Th1 stimulators. And then the Th2 stimulators were pretty much antioxidants, like green tea extract, pomegranate extract, acai extract. Those things were on the Th2 side. And one of the things that I observed initially with working with Hashimoto's patients is that some of them could not handle Th1 support, some of them could handle Th2 supports, or vice versa. Some can handle both, some can't handle any. But we would just observe this by looking at immune panels and seeing what patients came in telling us about them. Part of the reason that I haven't really included the Th1, Th2 protocols in this conference is because back then, 10 years ago, we had labs that really offered us very good Th1, Th2 cytokine stimulated profiles, and we can really play this game much more efficiently. Since these commercial labs are not offering these tests that are commonly used in research circles at this point, then I didn't really want to spend a lot of the course material time on it, so that's why I didn't talk about it too much. I know that Cyrix is hoping to have a Th1, Th2, Th3, Th17 profile, and that may change how we approach looking at the system more, because then we'll actually have laboratory tests to look at it more. But just realize some people can't handle immune stimulators that have Hashimoto's. So other people, that's the only way they feel better. So there's some individual uniqueness. I'll talk about that more when we get into treatment, but it's a pretty good question. Next question. What is the most common cause? What is the most common secondary autoimmune disease you see in Hashimoto's patients? We see anti-parietal cells and anti-myelin antibodies, but I'm wondering what you see. Well, for sure, the most common autoimmune Hashimoto's is celiac disease, transglutaminase 2. And then the next most common autoimmune reactivity we see is neurological autoantibodies, just like you. So if you're seeing a lot of anti-myelin antibodies, I'm seeing the same thing. So I'm seeing a lot of co-autoimmunities in neurological tissue target proteins, whether it's GAD65 or cerebellum for cerebellum autoimmunity, or just basic myelin protein that we see. So there's a lot of concern with neurological autoimmune reactivity in Hashimoto's patients, and it is a very common autoimmune reactivity, the most common being celiac, and then second being neurological tissue. Let's go into the next question. I have a patient whose symptoms flare up when she fasts or tries to do intermittent fasting. Is this from hypoglycemia? So this is a good question. So technically, intermittent fasting or fasting in general helps most patients with autoimmunity to some degree, because when they go into a fasting state, they decrease their protein triggers and their autoimmunity has a chance to calm down, and then they get into a fasting state that promotes something called autophagy, where they can regenerate cells and they can reset their immune system and have some really significant benefits from being in a fasting physiology. However, there are some people who can't effectively process fats, and one of the things that has to happen is, in order to get into a healthy intermittent fasting state, is you got to burn off your sugar and then basically get into a state of ketosis where you can burn body fat. There's some people that are so maladapted in their ability to use ketones that if they try to fast, they actually get huge insulin surges and huge catecholamine surges, and that actually triggers their autoimmune response. And the best way to fix this is to have them slowly transition into ketosis for a few months, and then get adapted in ketosis where the body can effectively use fats, and then they can start doing some intermittent fasting, and that can help make a difference with these profiles and these adverse reactions. Now, there's some people who have a hard time getting to ketosis. The number one reason people have a hard time getting to ketosis is that they're too sedentary and they're still not eating enough fats and too much protein. Most people that feel like they can't get to ketosis, it's really because of those factors. So you get them to exercise more, and you get their dietary intake, and you see they're eating way too much protein to get into ketogenic state. So you have to cut down on the protein and really increase their fats, where 80% of the calories are coming from fat, and then they can eventually get into a ketosis state. Once they're in ketosis for a long period of time, if they measure their urinary ketones, they'll see that their urinary ketones are no longer elevated. And once that starts to occur, and they just will notice is that they're just not hungry for the first meal and then the second meal, and then eventually they'll get into these states where they're doing like intermittent fasting, like a 16-hour feeding window and 18 hours of fasting, and some people go longer, but for them it's not hard anymore because their bodies become adapted. Next question. How does CBD or THC impact Hashimoto's, Th17 or Th3 cells? So cannabinoids have a very powerful immune modulating effect, and it is a game changer for some people with autoimmunity to some degree. So it should be, I didn't put any research studies or significant papers on this in your notes, because most of the stuff that's been done on CBD has been done with general autoimmunity, not so much with Hashimoto's, but it's definitely something to consider. The CBD is really the key thing we're after. THC is what really gets you stoned, but the benefits of the immune system modulation are really coming from the cannabinoids. So you really want to make sure you have the highest cannabinoid content compound. If you're just getting stoned with high THC and low CBD, then you're just creating oxidative stress and inflammation. So you really want to make sure that you're using the CBD portion of marijuana, not the THC, when it comes to immune modulation. Okay, next question. What is the most common environmental trigger you see with Hashimoto's? Well, food is the most common trigger. It depends what you define as environmental, but as far as food goes, it's going to be, without question, gluten. As far as pathogen goes, the most significant pathogen, or H. pylori and hepatitis C, the most common. And if you talk about chemicals, the most significant is definitely BPA, plastic. Devastating for the thyroid. So those are the most common triggers. We'll talk about those in more detail as we get into part 2. Can you please explain whether Hashimoto's patients are more vulnerable to viruses and how they should protect themselves? So, when you're looking at viruses, one of the things that happens with Hashimoto's and autoimmune patients is their immune system becomes significantly compromised with uncontrolled autoimmunity. The white blood cell count drops, and when their white blood cell count drops, many viruses that are already in their body tend to relapse, and they can cause some significant reactions. The most common one being Epstein-Barr virus. So, ultimately, the goal is control the autoimmunity in the immune system to make it healthy enough so the total white blood cell count never drops. And if that occurs, that would be the best protection against viruses. Now, next question. Are you saying 14% of the population has thyroid antibodies? What portion of those go on to become hypothyroid? So, the studies are showing that 14% of the population is between 10 to 15%, depending on which paper you read. But yeah, there's a significant portion of the population that develops these antibodies, and virtually all of them go into a hypothyroid state over a period of time. The paper I showed you in Autoimmune Reviews showed that it was about 7 years. They used to think that thyroid antibodies exist with a lot of people. It didn't really matter. And then as time has gone by, researchers clearly show that these are predictive antibodies that for sure confirm that over time, nearly 100% of them will actually develop hypothyroidism. Next question is, my understanding is the body can only use T3, but does T4 serve only purposes to be converted? No, there's actually direct effects of T4 on tissues, just not as significant as T3. T3 is just more impactful, but T4 and T3 are both important. But T3 is really the one that has the biggest impact on the metabolic rate and physiological interactions. Next question. What is the best way to test for an increased SIGA? So if you're measuring your secretory IgA just to look at your immune barrier protection, the two main ways to test it is saliva or stool, and they don't necessarily correlate. If you're trying to look at your intestinal immune barrier function, then stool SIGA is probably the best way to check that. If you want to take a look at your mucosal protection that's happening in your respiratory tract and your respiratory system, saliva is an accurate way to measure this. So saliva for the upper respiratory mucosal membranes for SIGAs is very good. And for the GI tract, you want to do a stool SIGA. Next question is, what is the difference between IgA, IgG, IgM, and why do they matter? Well, so these are all different immunoglobulins. And the key thing to understand about them is that they're different for foods and different than pathogens. So with like a infection, let's say a viral infection, IgA is not really that significant at all. And what we know happens is in the acute response of an active infection, like a viral pathogen, IgM goes up. And then once a person develops immunity, then they start to see the IgG levels go up. And IgG is associated with immunity. When you look at food proteins, that's different than a pathogen. With food proteins, IgG, IgM, and IgA can all go up, and they usually have high correlation with each other. And they're just showing you that there's an immune response to food. And then IgE with foods lets you know that it's an actual allergy versus a sensitivity. So the key thing is that most people make a mistake about is they don't understand that IgG, IgM, and IgA against food proteins is different than pathogens. When it comes to pathogens, M is acute and G is a better indication of immunity. Let's go into the next question. If we feel out of our depth with Hashimoto's encephalopathy, what are the best options for the patient? Patients with Hashimoto's encephalopathy, they should be on steroid therapy. They need to calm that inflammation or that brain is going to get fried. It's going to get degenerated. It's going to get destroyed. So if anytime you have a Hashimoto's patient that starts to develop stroke-like symptoms and delirium, and they're really just all of a sudden have this acute onset, which looks like a stroke or seizures, and their antibody titers are really, really high, a trial of steroid therapy is the best way to know, and it's actually one of the best treatments to calm that inflammation. At the end of the day, you got to control the autoimmunity, but it's a very significant flare-up, and usually they happen more than once. So once the person has this episode, it's really letting you know that there has to be some really strong efforts to manage their autoimmune response. Okay, next question. Are you still suggesting salivary adrenal testing? How do you incorporate those tests into your overall treatment strategy? Well, when you look at stabilizing blood sugar issues, an adrenal test can be very useful to you to let you know what their daily cortisol output is. The limitations of teaching a course with so many hours in it to get over the key concepts, you have to delete some information. So adrenal salivary tests are very good to look at cortisol levels, but we're not going to be talking much about them in this course. In our next module, when we talk about blood sugar management, diabetes, and insulin resistance, we'll talk about the research behind this much more. Anyways, thank you all for your attention, and thank you for the questions.